Hey, in this video we're going to look at the first two of the exponent rules. So we should all know what exponents are. Exponents are the, superscript, the little number up to the top left of a base. And they just mean that you multiply that base together. The base is the number, the variable, the x, in the case of x at fifth, times itself that many times. So if we have x at fifth, that means x times x times x times x times x. If you have something like x squared, that just means x times x. So what happens if we're multiplying common bases? Well, say we have x to fifth times x squared. Well, we said x to fifth was 5 x's, so that'd be 5 of them. X squared was 2 x's, so we would have a total of x to 7. Instead of actually writing it out, we can do a shortcut and just add our exponents. So common bases mean the same number or same variable. So we still can't mix variables. So say we have something like 3x squared y to the third, that times 4x to the 8th y to the 7, sure. If I'm going to multiply this together, I'm going to rewrite it. Multiplication is commutative, which means I can switch the order. So I'm going to put my 3 and my 4 next to each other. They'll still be multiplied. My x squared and x to the 8 next to each other. And my y to the 3, y to the 7 next to each other. And then I'm just going to use my multiplication rules. So 3 times 4, I just know. That's 12. X squared and x to the 8. I'm going to add my exponents and get x to the 10. Y cubed and y to the 7. Add my exponents and get x to the 10. I can try one more. Say I have 2 x to 14 y, 5 x to the 3 y to the 11. Okay, I'm not going to rewrite it. You don't really have to. I just wanted to show real quick why it worked that way. I can just multiply the common things together. My numbers, 2 times 5, should just give me 10. X to 14 and x cubed, I'm going to add the exponents and get x to 17. Y, I don't see an exponent there. Where I don't see an exponent, I'm always going to put in 1. If x squared gives me 2 x's, just having a single x would be x to the 1. So that's just y to the 1. So y to the 1, y to the 11 gives me y to the 12. That's it. Let's look at my second rule. Instead of multiplying common bases, say I was going to divide common bases. So let's stick with x to the fifth and x squared. And let's write it so we're dividing both ways. So we have x to the fifth on top over x squared, or x squared on top over x to the fifth. Again, we can write it out for the first one. I got 5 x's on top, 2 x's on bottom. Something over itself just cancels. So I'm left with x to the third on top. That's where my 3 x's were left. Let's do it the other way. I would have 2 x's on top, 5 on the bottom. Again, something over itself cancels to 1. So I'm going to have x to the third on the bottom. I need to write the 1 on top. Over here, my first one, I didn't need to write the 1 on bottom because we know something divided by 1 is just itself. But I do need to write the 1 on top because 1 divided by x to the third is not just x to the third. Let's look at a shortcut. Let's see, x to the fifth over x squared, I ended up with x to the third. X squared over x to the fifth, I ended up with x to the third. So both times I subtracted my exponents. The first one, the answer ended up on top. The second one, the answer ended up on bottom. And they ended up there because that's where I had more of the bases left. So I subtracted exponents toward the larger one. So toward the largest. So let's try that with a few. Say that I have 5 x to the 10 y squared over 10 x to the 3 y to the 15. Gonna go ahead and divide. I'm gonna divide each part. Look at my numbers. 5 over 10, I should be able to simplify. 5 goes into both of them. 1 over 2. Okay, then x to 10 over x cubed, that's common bases. So I'm going to subtract. I'm going to get x to the 7. My larger exponent was on top, so I'm going to get x to the 7 on top. Y squared over y to the 15, I'm going to subtract. My larger exponent was on bottom, so I'm going to subtract and get y to the 13 on bottom. That's it. I don't really need that 1 in front of the x to the 7, since if you don't see a coefficient, you know it's 1. So I can just get the x to the 7 over 2y to the 13. Let's try another one, and then we'll combine these two. So 3x to the 18, y to the 4 over, let's say 6x to the 23, y to the 30. Okay, so again, my numbers, I'm just going to simplify. 3 over 6 would be 1 over 2. My x's, x to the 18 over x to the 23. Larger exponents on the bottom, so I'm going to subtract and get x to the 5 on the bottom. Y to the 4 over y to the 30th, larger exponents on the bottom, so I'm going to subtract and get y to the 26 on the bottom. This time I really do need that 1 there on top, so I'm going to keep it and have 1 over 2 x to the 5th, y to the 26. Let's try one where we're combining both ideas, so let's get something like 5 x to the 4, y to the 3, over 2x to the 6, y to the 8, why not, over 15, x to the 30, y. Okay, so let's start off by getting stuff out of parentheses. So I'm going to go ahead and multiply. So I'm going to use my first rule of exponents and add the exponents as I multiply. So let's see, first my numbers, 5 times 2 is 10. X to the 4 times x to the 6, if I add it, I get x to the 10. Y to the 3, y to the 8, if I add it, I get y to the 11. Denominator, wasn't in parentheses, so I'm just going to rewrite it. 15, x to the 30, y. So now I'm going to go ahead and divide, which means when I'm dividing my common bases, I'm going to subtract my exponents toward the largest. Start off with my numbers though, 10 over 15, 5 goes into both, so 2 over 3. X to the 10 over x to the 30, largest exponents on the bottom, so x to the 20 on the bottom. Y to the 11 over y, again I don't see an exponent, so I'm going to write that as y to the 1, largest exponents on top, so y to the 10 on top. That's it. I can't simplify anymore. So next video we'll look at the next two rules of exponents.